lights are those lights with wavelength. What's the wavelength?
Below 400 nanometer.
Yes, the cutoff point is like 400. Below, smaller.
Yeah, smaller than 400.
The smaller the wavelength number, the stronger the energy. Then likewise, the other side, all the
After
colors,
700.
the higher the wavelength number, right, the lower the energy.
Oh,
So, number 4, a bit tricky, so a lot of students don't quite understand. So, first part, this one, again, go by definition. So, when we talk about GC separation, the chromatography separation, we have introduced you this technical term, colon efficiency. So, this one, you just need to remember the higher the theoretical plate number, the better the colon efficiency. So that's why for the experiment we expect a higher efficiency always in general. So that's why if you remember this, then you straight away look out 2 answers, A and C. You can look them out straight away because they have a lower number, so it's not the best performance. But the tricky part is for B and C, colon B and colon D, colon B and colon D, both has the same theoretical plate number. In that case, how to choose the colon? And then the expectations is we need to see from the chromatograph the sharpest peak, compound peak. So I think we didn't really introduce you a theory that the mathematical equation would define that what's the difference between a longer or shorter colon, right? But you can try to visualize in this manner. So that's why the colon, right, is like a tunnel, right? When your analytes going to travel through. So if the colon is shorter, that means the compound can travel through the colon in a shorter time. That means the speed of the travel is faster. If the things travel faster, right? Detector is the eye. When the eye detect the thing, if the thing travel very faster, then of course the shape going to be like kind of be compressed, right? Then it's sharper. Then if the column is much longer, then the compound can travel quite slowly. Then in terms of the detector, because the pick up point by point by point, because it travels much slower, then you pick up, and then the shape becomes fatter, broader. So if you try to sort of visualize this way, then you probably will choose the answer B, which is the correct answer. And okay, last one. You see, MCQ 5 questions, 10 marks, usually. Again, this is a UV-Vis question. When we use the UV-Vis meter, then what is the condition? What is the requirement? What's the requirement?
Is it?
That's by definition, right? Just by definition. So now you can see when teacher design a question to evaluate whether you understand what we have learned, right? So far we have only 2 techniques, right? And you can break it into 3 different areas for you to remember and organize the information. First is always principle, and then the underlying principle. For instance, this question, we introduce you the UV-Vis instrument, UV-Vis spectrometry. Then you need to understand what's the definition and then what is the underlying principle of this particular technique and what is it for, and what is considered the advantage or what is considered the disadvantage when we apply research, so on and so forth. So this part under the principle or theory part, right? The second part is the instrumentation, the hardware, the different components. In particular, we say that GC technique, we have not really tested you. We have not tested you. So GC the instrumentation, in a way, it becomes important. For instance, different type of detectors, different type of injectors, right? And different columns, how to choose the different columns, so on and so forth, right? And then the last part, application. When we apply these techniques, right, there are two things. When we talk about these two techniques, there are two things. One is how can we apply this particular technique to identify the chemical compound. This compound identification. The other one is quantification, like the experiment you just did right a week ago. We use GC technique to quantify ethanol. We try to quantify ethanol presented in that product. That product is a rice wine, right? Then how to do the quantification? How to do the quantification? So far, we have learned different quantification methodologies. How many? 2, 3, yes. Latest one, we use the internal standard method. That's the third one. So far, we have introduced you 3 different. So that's why now you need to understand there are 3 different quantification methods. So you need to understand all 3. In case the test give you a question, ask you to recommend or use an appropriate quantification method to solve a particular problem. So you need to understand all this, then you can decide, right, which one is most appropriate for that given kind of scenario and help you to solve the problem. And then the requirement is you need to recall how you usually carry out the experiment. You need to understand the process. Procedures by step A, B, C, 1, 2, 3. You need to summarize and briefly you mention how do you carry out. And then what is the advantage, the so-called competitive advantage. So for instance, why a week ago, the GC experiment, we need to use the internal standard, is to overcome certain difficulty. What is that? What's the advantage? So I very quickly, the most classical one, we call it standard curve. Standard addition, internal standard. So the details, you quickly go back to your notes, textbooks, and then your tutorial questions to go and do the revision. So this one, come back to late version. The so-called the requirement for the UV-vis application is, because this is based on the absorption of the light energy, right? So then this becomes a condition. Your target analytes need to come with this property. They need to be able to absorb the UV-vis, either UV or visible light radiation. Then we can consider this technique. We can apply this technique. If a compound, if you are given task in dealing with this particular compound, there's no UV-vis absorption at all. So that means in the first place, this technique, this instrument is not applicable for this scenario, right? So we can forget about this technique. Okay, so that's MCQ questions. So you can see all 3 topics will be covered, right? And then the short questions, you look at the question B1, and this one looks a bit familiar. I recall we have a similar tutorial questions. If a lab performs a type of experiment, you get some data. How to do the data analysis? So actually, the first one is quite, I should say, it's quite basic. The question is quite basic. So basically, we are asking you to figure out the fundamental statistical terms. Let's say we have a set of data, then how do we figure out the mean of the result? standard deviation. Standard deviation during term test. So what you need to do is actually it's quite straightforward, but this one, usually some of students still make mistakes. So there are no choice that you have to press your calculator carefully and correctly. And then the calculator later will give you. So sometimes it's very hard to know whether you did correct. So that's why you have to do it slowly and carefully. Okay, ISD. ISD is by definition is you need to figure out the standard deviation. Then you divide the standard deviation by the mean of the data set, right? And then multiply by 100%. So standard deviation and relative standard deviation both are indicators of the how precise is the data set, right? So those individual data, how precise are they? That means how close are they with each other, right? So that is the laboratory A. You do exactly the same for lab B. Okay, so that is a B1A. But importantly, you need to understand for question B, based on the our statistical analysis and based on the observation, lab observation, I mean the original data points, right, and then original results. So can you comment that which lab may most likely, which lab has a systematic error, right? So that's why you need to understand what is systematic error, right? Is it laboratory A or laboratory B? And importantly, you need to be able to justify your statement, your answer, right? So look at this set of data. Can you quickly comment which lab may come with that systematic error?
B.
Which one?
B.
B, laboratory B. Your justification? Your reasoning?
Cause the numbers are a bit off, like 31, 31, then got 33, 32. I don't know, is it like
Okay, so that's why this one you need to understand the fundamental concept very clearly. So what does a systematic error mean? What does it mean?
is the error done by human, and there's instrumental error, and then the instrumental error, and then what's the one more?
Okay, that is not the key point. So that's why I will suggest this part. I realize some of students always get confused. So that's why I suggest you to really go through the original kind of definition and understand it very, very clearly. So in very briefly, right? Briefly, I share with you my understanding how I remember this. Again, go back to language itself. Systematic means something with a very clear pattern. Systematic, right? And then another one is random. Random is you can't clearly observe there's a pattern. So in another word, systematic error, I interpret this way, is always you can clearly observe a trend, right? A trend means it's a clear pattern. No matter how you do this, no matter how you do the experiment, the result always is on a particular, shows a particular pattern. For instance, it's always higher. It's always on high side. Or it's always, you always get a lower result. But of course, you need to understand this is that you need to have a reference, right? You need to have a benchmarking point, right? Or either always higher or always lower. And then random, as the name implies, right? The name implies it's kind of it's quite random, right? Sometimes high, sometimes low. There's no clear pattern So if we understand this, then this question probably is a bit easier. So we take a closer look. Laboratory A, all 6 data points, all the results are kind of at 33 or above. In particular, given this information, we know the so-called true value, the theoretical average is 32. Then you take this into consideration. So all results are greater than 33. Then I can comment that is a pattern to me. Right? So that's why I can comment that probably most likely laboratory A comes with the systematic error because that's very simple, right? Because all results are higher than the average. Right, so likewise, question number C. Which laboratory produce you a more precise? Again, this one go back to definition because just now we work up the RSD. RSD in comparison, right? It's already figured out how is the so-called how are the results scattered around, right? So of course, the lower the percentage, RS percentage, the more precise are those data, right? So in comparison, one laboratory A only give you less than 0.6%. Then laboratory B, the ISD is close to 3%. Of course, in comparison, laboratory A has a much lower ISD. The results is more precise. Okay, that is by definition. Okay, B2. So you see B1 is again go back to topic 1, more the generic concepts, PIA concepts. Then B2 is a GC question. You see, in the question, you are told that a particular type of instrument detector is used. For this question, is the mass spectrometer is used. Then you need to be able to recall what is the advantage and what is the disadvantage by using this particular technique or detector, right? If our actual test paper, I can very simply, I can give you a very similar question. I just simply replace detector with a different type. Maybe I say, hey, now we're going to use a TCP. Then can you share what is considered an advantage and also the disadvantage of this technique? So you may comment that, okay, MS detector is very sensitive, but the cost is high. Because you say only one, you need to read question carefully. If you mention at least 2, then you need to. For example, MS, other than very sensitive, is also very accurate, means it can identify the compound. The identification power is very high. Means it can identify the compound very accurately. Okay. All right. Second one, B. B is also quite a straightforward question because that's by definition. Don't worry, in the term test, the mathematical equation will be provided. Right? You just need to understand the concept. Then you plug in the actual data given. For instance, you need to understand what is the TRA means, right? Then you plug in the data correctly, the retention time correctly. And then WA, right, is for that particular compound, the peak width. then you plug in all this data, then you can straight away figure out the resolution is close to 1.2. And then naturally, we may get this question C, right? You have calculated the resolution of these two peaks. Then you need to comment. Right, the performance of the experiment. Right, it says that you comment whether this kind of resolution, that's based on the actual experiment performance. This resolution, is it good enough? So that's why you need to comment that given the GC separation criteria, we say that in terms of resolution, it must have 1.5. Right? Anything less than 1.5 is not considered a good GC separation. So that's why you can comment that the separation for this actual experiment is not sufficient. The resolution is not sufficient. It can be further improved. Right? That means the method conditions and parameters can be further optimized. Alright, the last question, again, go back to, you see this term test paper actually tests you a lot of quite a fair bit of the fundamental concepts learned. Right, for instance, the definition of the error, resolution, and this one is the theoretical plate number. So again, the equation will be given. I mean, this equation will be given. Then you just need to plug in the given data, right? And if you do the mathematical calculation carefully, slowly, you'll be able to get the number of the theoretical plates. Then by definition, peak plate height is also very straightforward. And units are important. You need to pay attention to units. Some terms we use unitness. For instance, number of plates, right? And then the absorbance, all these unitness. Then plate height. Again, by definition, you need to indicate clearly what is the unit. Is it in meter or centimeter or milliliter? You need to indicate clearly. Right, that's our B2. Then how about B3? B3 goes back to the UV question again. Right? As I said just now, each technique we can kind of split them into three major areas. One is the underlying principle, and this one is related to the principle, right? Whether this technique is applicable or not. Why is that so? So same question. So if you are given a task, you're going to study propene, then you need to recall the principle. Why does this technique work in this case, and how does it work? Right? Why it works is because we always need to remember, because it can absorb the UV or visible light radiation. Then we need to think about, okay, the chemical we're going to study now, does it come with this property? Can it absorb now? Right? If you understand this, then we think about the chemical structure, then we can straight away comment. Because this given compound, also for our target, is a alkene, right? Carbon-carbon double bond. So unsaturated, this carbon-carbon double bond, we learn the organic chemistry. Straight away, the double bond will be able to absorb the UVBs. So that's why the technique is applicable for studying this particular chemical compound. So you do the same for whatever compound is given. For instance, the second one is an inorganic salt solution. There's no light absorption, right? Like the salt, sugar, right? All this, you dissolve in water, can it absorb? UV light, colors, all this, right? So you use a color torch, right? Use red light, and red light just pass through, right? Transparent pass through. And actually benzene, this one also yes, because of the you focus on the functional group, right? And then benzene ring also has come with this property. You'll be able to easily absorb the light energy. So it's UV is applicable. So if you so far you probably can understand a bit when you give a question, right? How we design the question and evaluate which learning point. Okay, B4, another important question and somewhat straightforward. So that is the quantification of a UV beast. That is the BS lambda law, right? So you need to understand what each individual parameters means, right? And then a lot of these are constants, and then the values are given. Then you just plug in accordingly, right? For instance, the absorption coefficient, right? And then the cuvette we use, how big is that? The distance for the light energy travel through, like for instance, is 1 cm. Then concentration. Sometimes absorbance is known. From there, you calculate the corresponding concentration, the product concentration. Or the product concentration, when you prepare standard, product concentration is known, right? Then you can calculate the theoretical absorbance. So that's how you look up. And then the calculation is quite straightforward. All right. And 4B. 4B is a question. Again, we kind of quite frequently we use this kind of a question to evaluate whether you understand the application of this technique or not. You need to be able to explain the limitation of this particular technique, right? Clearly. So for UV this application, so that explains why when we prepare a standard solution, we need to pay attention to the concentration. And then the product, if we receive an original product, we usually need to do some treatment, sample pre-treatment, and after that, we even need to, for our actual experiments we've done so far, we need to even further dilute the solution. Why is that so? It's because the quantification principle, right, is based on this PIA's law. So absorbance is proportional to the product concentration, but that so-called relationship is only valid in low concentration range. Why is that so? Because when concentration gets higher and higher, then those molecule compounds, right? Their ions are getting closer, and then they will interact with each other more frequent. That will affect and decrease their ability to absorb the UV radiation, right? And then it will result in a negative deviation from the Beer's lambda law. So that is the limitation of this technique. So that also explains in the actual practice. So we usually need to be very careful to select the standard solutions, the concentration range, and also we need to be mindful when we prepare the actual product. When the actual product contains a lot of our target analytes, then we need to dilute. But how do we find the appropriate concentration range? Make sure the Beer's lambda law is very. So this one we have to do in the laboratory. Usually we need to do try and error and try it out. Right? think that's a few short questions, right? So it covers both the GC separation and also the application of the UV vis meter. So I show you one more question, which is a long question, right? And this long question comes with 20 marks, right? 20 marks. So the scientists did an experiment. The scientists did a GC analysis. Now we know that actually the product contains 5 different chemical compounds. We need to be able to sort it out, these five guys, right? And then the scientists did the experiment, and then we got a result like this. You look at this result, GC result, very carefully. Do you have any comments in terms of how good is this experiment? I mean, how is this experiment done? Is it done? Is the experiment done well? I mean, the results are all in good quality. It gives us the right information and correct information and accurate information. So with this very limited information, can we comment on that based on what we have learned so far? Actually, yes. To look at this experiment, this actual experiment results. Do you have any concerns with the result?
The 2, 3, and 4 very close together.
Yeah, exactly. So that's why we need to again, I said again and again. First part, principle, always relate to principle, and then hardware instrumentation, different kind of hardware, and then the application, quantification or identification. So go back to principle. Each time when we gas chromatography, the fundamental objective is to separate things, right? So if we record this, then we look at this result. Pick number 2 and number 3 and number 4. They are still together. Then in a sense, the separation objective is not met. So that's why that is our evaluation criteria. Then straight away, I do have a concern, right? The experiment was not done properly.